Hey everyone, this is your second episode of the Zephyr podcast. I'm Benjamin, your co-host.
And I'm Fabio, your other co-host. Benjamin, what do you mean episode 2? We're nerds. We start counting from 0. This is episode 1.
Sure, this is the second episode. I think that works, right? We can tell it this way. We still don't have an intro music, right? I think that's coming next if we stick to this format and if we stick to a weekly cadence. I think we deserve an intro music or even a background music as well. I don't know. That would be too much.
Is this a call for musicians in the project?
I wouldn't mind. That would be great.
There you go. We had the MIDI stuff recently, so you never know.
Yeah, maybe Titouan. I'm calling out Titouan right on the spot. But maybe we have some musicians. We can give us a really cool intro, Zephyr themed intro music. That would be great. So yeah, we are back. We are recording this on Friday. A whole week of Zephyr stuff happened. You might remember from last week, we made kind of a joke that by the time the first episode would be going live, maybe the videos from Zephyr Developer Summit would already be out. And turned out they were. I think they beat us by an hour or so. Everything's on YouTube. We will be putting the links to the YouTube playlist in the show notes. So yeah, there's 45, 60? Was anywhere between 45 and 60 talks. I don't remember exactly, but it's really a lot. It's hours of content. The vast majority, if not all the talks, are actually really, really good speakers, really good content. The slides you can also find online if you on the conference website, etc. If you really want the actual PDFs and so on. But otherwise, the recordings are really good quality. You can see them. All the presentations.
So it's 48 recordings, and they are on the Linux Foundation YouTube channel for some reason, not on the Zephyr one. I guess that we took the whole stage for the Zephyr channel with the podcast. Are we gonna post a link in the show notes?
Yep, and I still have to go through some of them. I think I mentioned last week. It's always a challenge when you're attending the conference in person to actually find the time to go and see talks. So yeah, lots of stuff to catch up on. Really looking forward to doing that maybe this weekend. So yeah, still working on the format for this podcast, but bear with us for a few weeks. We will be coming with maybe a really structured way of going through things. One thing that I think we will be doing every time, one way or the other, is looking at new boards that are contributed to Zephyr. It's every other day, I think, if not more, there is a new board being contributed to Zephyr. Oftentimes, it might actually mean that there's also new SOCs being enabled at the same time, right? So this week, quite a few Cortex-A based boards. I think the NXP contributed the Freedom IMX93. There's a few others. We still see a lot of Raspberry Pi activity, either good old Pico or Pico 2. One thing that caught my eye is the so-called Raspberry Pi Pico probe or debug probe. And I think this one is quite interesting because I think the way I understand it is it's a good old Raspberry Pi Pico, which you can use to blink LEDs and whatnot. But you can also use it as a debug probe. And Fabio, what does that mean? Because I see some support in the Zephyr 3 for things like CMSIS, DAP, and so on. What does that mean for folks?
Yeah, so I saw the board and I immediately jumped on it because I was working on something similar at the same time. So the board, as you pointed out, is something from Raspberry Pi, and it is meant to be used with their Pico board for doing source level debugging. So it has an RP2040, a bunch of LEDs, and some dedicated connector for SWD and the serial port, so you can get a console output from your target board. And the reason why it's interesting is that the firmware that Raspberry Pi deliver with the board is it's using a package called SimSysDApp, which is distributed as part of SimSys, the ARM HAL. And we actually have support in Zephyr. This has been this is maintained by Johan, the USB maintainer, and this is something that you can use on any device that you want, that is supported with some caveat. And basically, it means you can turn any board that has a USB controller into a debugging probe with basic functionalities, which is reprogramming and reading, writing from memory using OpenOCD or PyOCD or other support packages, I guess. So with the Pico probe, what is really interesting is that by setting the device tree appropriately, you can use the sample that we have in Zephyr, which is lives somewhere under samples, and you can actually use the device for the intended purpose, which is a debugging probe. And the target, it does not necessarily have to be a Raspberry Pi. And in fact, I've been using a similar setup to debugging some STM32 and even some of the Nuvoton chip that you use in the EC. And what is also interesting is that not only the debug access port is supported, but the board also has a port for the serial connector, and you can implement a bridge from a USB CDC ACM port to a hardware port without having to write any code. And this is also something that is now supported for the Raspberry Pi Pico probe, and it happens automatically when you build the example. So if you're looking for some reference for some code to embed a programmer in your own custom board, which is something that can be useful if it's a product that you're giving to your internal users, this is a good design to study, and something that is much easier to implement than going for a J-Link OB or some other commercial device. It's completely
different. I remember seeing your pull request, and like enabling support was like just maybe 20 lines of like device tree enablement, right. And that's it. What would it make sense? Like, because like what you did was basically just enable the basic functionality. Would there be opportunities or room for like customizing the way the debug probe works, like, and make it like a smart debug probe? Or like, is there anything we could play with and like leverage some of the Zephyr other features and subsystem to do interesting stuff?
Yeah, I was thinking about it. I haven't really played too much with other extension, but one thing that came to my mind is maybe you need an automatic programmer, something that you plug into a target board and automatically flashes a firmware. That is probably something you can do fairly easily with this kind of setup. Or maybe you even want to have some testing and validation and you want to use the serial probe, but the board is nothing particularly special. It's just an RP2040 with 2 dedicated connector, but it's cheap.
Yeah, no, that's cool. So yeah, that's one of the many. It was a handful of new boards this week, and I'm sure next week we will have a few more to talk about.
At the rate that we're going, the number of boards that we support is going to explode. Like we had 5 this week alone.
Yeah, and 830 by the time we are recording, I think 830 boards in tree. Like we mentioned last week, also lots of new shields. I think that's also a handful of new shields since last week. SparkFun, Adafruit, Micro Electronica. So something else in the weekly news. I think it was basically literally happening while we were recording last week. There was a bit of a CI meltdown, and like for a good half day, if not more, like all the pull requests being made by contributors to the project and so on, we are pretty much stuck and getting delayed. What happened there, Fabio? Like, were you involved one way or the other to fix it,
Yeah.
maybe more than
Uh,
just
or,
fix.
or causing it. Yeah, I might have had a small part in the situation. I didn't cause it, so yeah, don't shoot at messenger. But yeah, so it hasn't really been fully troubleshooted, not by me anyway. I was minding my own thing, and I noticed first the macOS runner were lagging really bad, and then all of them started to break. So my best understanding of the situation is that GitHub had an issue and it was not scheduling runners for a while. And then when it finally started scheduling runners again, they all started at the same time, and there was a big backlog of pull requests. Then they started to process the pull request, and what happened is that we ran out of RPC, and so some jobs started to fail because they wouldn't handle the out of RPC quota error. And then the part where my work didn't help much is that we have two workflows that depend on each other, and the second one polls the first one for completion, but the first one failed, and the loop that was waiting for it was not accounting for the job failing, so it started to spin to infinity, and that started taking workers as well. So that was a bit busy. It was an interesting Friday afternoon, and things went back in shape eventually. But the whole situation made me think it would be cool to discuss what do we do, what should you do if your pull request is failing the workflow, the integrated CI that we have. There's a bunch of use cases. So Benjamin, what do you do when you fail the pull request?
Yeah, well, because there's quite a few checks. Like those of you who've contributed to Zephyr, and actually, I would be interested in your feedback. But maybe some of you find this actually intimidating. Like I think it's really, really great to have so many checks happening automatically when you do a pull request, but it's literally thousands, right? And checking compliance and running unit tests and license, etc. And
yeah, I think that the first thing you need to do is actually realize that your pull request is failing some of the checks, because we have so many that sometimes they generate maybe a bit of noise. And I wouldn't say often, but I occasionally see people that open a pull request, some of the job fail, and they do not see that the job is failing, and then they let the pull request sit for a long time. And one thing that is important to understand is that a lot of maintainers are busy, and if they see that the pull request is not passing CI, they're probably not even going to look at it until it's fixed.
A couple things to say to that. Like one, you should be getting an email. Like when you do a pull request and it fails, so it might take anywhere between like 5 minutes and 30 minutes maybe for the actual failure to be detected and reported. But when you do a pull request, keep an eye on your inbox, because if something fails, you'll get an email from GitHub telling you, hey, you might want to have a look. And some of those tests that fail, I think it's also important to know that you can run many of them locally, starting with the one that maybe fails the most easily, the compliance check. Like when you do a pull request and a contribution to Zephyr, there's a bunch of quality standards and guidelines that we want to make sure that everybody follows. Everything from like formatting and like using proper license headers and various linters. If you're contributing Python code, we will run some Python linters, and same for YAML files, C files, obviously. And so those tests are pretty easy to run locally. We have a script in the Zephyr code base, like the check compliance script, which you should very, very feel very, very welcome to run locally. Like it will catch many issues. Do it basically, because there's always going to be a white space that you forgot somewhere or anything. So this one I think is really important, and because like if you did something wrong, this will fail. Like there's no way around it, and this will, to Fabio's point, this will kind of delay the review of your PR.
Yeah, and it takes this is one of the fast one, but it still takes a few minutes, and it may take a few minutes to schedule as well. So it's a good thing if you're iterating on it to run it locally, and then at least you can be sure that you're past the first level.
Yeah, I think I need to have a look at it some more at some point. I think while not necessarily making it mandatory, we could probably provide some automatic way for people to have the proper hooks on their local environment, so that whenever they try to, whenever they do a commit, if they opt in for that, we could run the compliance checks. That could be, I mean, obviously some people might not want that, because if you know what you're doing, you don't want to check compliance for every fix-up you make.
Yeah,
but
I would absolutely hate it.
Yeah, I know, but I think there's some tools that maybe we could experiment with. So yeah, that's one.
In fairness, we have it on our internal repository, and it was great because the same check would be, in our case, the same check would be run before the submit after all the reviewers reviewed it. So yeah,
because I mean, what I've heard from people, and I don't disagree, is that, I mean, if you guys know that my stuff is not compliant and you even have a script that I could have run locally, like how come it has to wait until it hits the GitHub servers for me to know that I did something wrong? Right.
Yeah. This is probably something worth having in the documentation for compliance, like how to have a Git hook about it.
Yep. Yeah. Food for thoughts there. And I guess the other thing that might get between your PR and your PR being merged is it needs to pass. I mean, one way or the other, there will be tests being run against your pull request, either because you ideally added them, or more likely because you just touched something that might impact other areas in Zephyr. So when you do the pull request, automatically Twister, which I think we briefly spoke about last week, will figure out a bunch of test suites that need to be run, and some of them might fail. And that also is something, I mean, if GitHub tells you this doesn't pass, oftentimes, most of the times, it's due to something you effectively broke. So look at what the job is reporting, and look at it's pretty detailed. Like it tells you whatever tests or tests fail, you can easily rerun them. It gives you the nice command that you can run. And so if you can reproduce locally, and if it feels like it's something that's related to your changes, well, you fix it. Sometimes it's not related, right? It might be that someone, like the main branch, is in a broken state. So, I mean, in that case, there's a few options, Fabio, I guess, right?
Yeah, that is maybe the more annoying case. Like first, you need to figure out if the problem is your change or not. If you suspect that the problem is on main CI, you can probably write a comment in the pull request and hope that somebody notices. But probably the best thing is to go on Discord. We have a channel called #CI, which is where CI issues get discussed and reported. So you could report it and see if somebody helps you fix it, or if it's being discussed already. Maybe PR help could also be a good one if you're not completely sure of what's going on. Ideally, you would contribute a fix. We're always looking for people to help out keeping the system running. One of the tricky things that happens if your change is not the source of the problem is that retrying the pull request after the problem has been fixed on main may or may not work, depending on the workflow. For Twister, it does. But if it's one of the other checks that fails less often, depending how the workflow is configured, you may have to do a rebase and do a force push. And also, likely you don't even have permission to retry. If we as people are working on infrastructure notice that some of the checks are broken, we often retry the pull request from you. But the last option and the simplest one is to rebase and push. The only problem is that you lose the approvals if you had any. So something to keep an eye on.
Yeah, one thing worth mentioning, there's, I think for some people, force pushing is something that maybe they've been told is bad, or like you shouldn't force push and like rewrite history, etc. Like in the context of pull requests, that's actually like it's encouraged. Like you want to, whenever, even when it's not about a failure in CI, you're being asked by the reviewers to change something in your pull request. Don't add new commits. Like you can fix up the existing ones and just whether you have one or several commits, just squash everything and force push. That's the whole point of working in a pull request branch. We keep it clean, and when it's ready and approved, then we do merge it with like a really clean history. But yeah, force pushing in any case will just retrigger the CI jobs, which is what you want. So one thing, some of the useful links as well when it comes to pull requests and so on. There is something where we PR help CI channel on Discord. If you're involved in Zephyr as a contributor, if you've done more than just one or two contributions, it's likely that you're starting to pay attention to the stuff you care about, and like you wouldn't mind giving a hand to review pull requests for, I don't know, like the data board you contributed or that driver you initially contributed. We have a nice pull request dashboard that you can and that we will again put the link in the show notes. This pull request dashboard can really help you. If you want to help the Zephyr community, you can easily find some PRs that are lacking approvals. Like people have been too busy to review some PRs, or some PRs don't have anybody assigned to them. Go have a look. Like this is basically just sitting on top of the existing GitHub APIs, just giving you a nicer view and nicer way to see what are those PRs that could use some love. So yeah, do check it out. Like, I mean, yeah, I use it all the time, like for my own backlog, but also for, like I just said, areas I care about, and I want to make sure that if some maintainers are struggling with the fire hose of PRs they have to review, you can help them.
Yeah, we should probably talk about the history of that dashboard at some point, because it's not necessarily Zephyr specific, and it would be cool if some other project end up adopting it. But hey, on Twister, another thing that maybe a lot of contributors are not really aware of is that there is also a run that happens every week on every possible combination of board and test right now. And that has been incredibly hard to maintain, and it hasn't fully passed in a very long time. So something that comes out every now and then are people looking for changes to contribute just to practice with the system. And that actually would be a good one if you're looking for just a random thing to fix. And open a pull request. We could probably link the list of jobs. That is actually pretty hard to find due to how GitHub works. So we have
I think we might have a link in the wiki. That's maybe
that's
a shortcut for that. But I think there's 400,000 or like anywhere between 300 and 400,000 tests. They don't all
it takes a long time. Yeah, but if we should probably raise more awareness of that list, and if somebody wants to take a look at what is failing, maybe for the CPU for the vendor they work on, those are all build problem. They are probably some weird combination of configs, but it's still something that should be fixed ideally.
Yeah, and just on the topic of you want to help and you don't know where to start, some low-hanging fruits, etc. definitely looking at some of the tests that are failing. On GitHub, we also have a few issues that are labeled as being good first issues, reasonably trivial changes that just grab an issue and work on it. And if not, I mean, you can always find me on Discord, find Fabio, and find like basically anyone on Discord. If you're looking to help the project, just come and say so on Discord, and people will be happy to point you to things that you could be helping with. So yeah. And kind of related, actually, something that's I think worth giving like a shout out to. We have a reasonably new community member who's been really busy over the last few weeks, month. Well, it's Kyle, actually. Like, for those of you watching the Zephyr Tech Talks, you might remember Kyle presenting all the work he did on the device tree LSP, the language server protocol for VS Code and Vim and whatever, to help people with all things editing device tree. But it turns out that the tool he wrote is something that can also be used for just like plain linting of device tree files. And so there's already a 100+ commits that were merged earlier this week, basically reformatting and cleaning up the entire Zephyr source tree when it comes to making sure that device tree files are fully aligned with our device tree guidelines and like have the proper indentation and so on. So that I think that's really really cool. And so that's one more linter we add to the mix, Fabio, of things we do to keep the code base as clean, I guess, as possible.
Yeah, I think it's a really valuable tool. It's consistency in the code is something that is very valuable for obvious reasons, right? Developer work by recognizing, especially in code review, your brain work by recognizing patterns. And if the file is all scrambled up and the styling is not consistent, it's very hard to do code review because you tend to focus on the format. So I think that having a linter for device tree file is going to be really good. Kyle is been doing a great job. You already merged. We merged his changes for, I think, tests and DTS.
That's the sample.
File. And things are on track for having all of the board fixed. One thing that came out from reviewing this change that I did not realize was that a lot of device tree file have been merged with the tab setting to 4 spaces, while we normally use 8 for the code. And this is very weird because I couldn't figure out. Like, I was seeing people doing misindented stuff all the time, and a lot of time you don't call it on a code review because it may be the only thing, and you think, yeah, whatever, no big deal. So this is going to keep all the files in check. And so one more tool in the CI arsenal. How many languages do we have at this point? Like, the challenge in keeping the style consistent in the project is that we use a lot. I was thinking about it. If you're picking a simpler bare metal SDK like Pico SDK or some of the other one, you're gonna have to deal with C and CMake, right?
Makefile, possibly. Yeah.
And Makefile. How many languages do you think we have in the repository, Benjamin?
I mean, I don't know. I mean, C for sure. We have C++. The build system, I guess, is a bunch of probably some good old make files here and there. CMake. Definitely a lot of Python. Assembly. And this is the topic for an entire episode, I guess. But we do use Python quite a lot for the macrobatics and so on, and like bridging the gap between device tree and C. I'm working really hard on adding more JavaScript and HTML, right? Whenever I work on documentation stuff. I'm sure I'm forgetting a few.
Yeah, so GitHub gives a summary, and it says C, Python, CMake, linker script, which is something you don't think about, but the linker system in Zephyr, it's probably worth a tech talk on its own if you know it well. Shell, some bash script, assembly, but we leave Andy doing that. and others. And others maybe include one Perl file, which is borrowed from Linux, though. So I don't know if we count it.
Yeah.
But we do have some level of linting for some of those, but not that many. But for Python, the situation is pretty good. Peter did some great work there. For C, we obviously have most of it. YAML, actually, I did it a few years back and did something similar, single pull request, changing 1,000 files, and it's been good to have.
Yeah, and I mean, to your point, it's and I appreciate that some people might feel that when as part of the review process, they're being pointed to like inconsistencies in their code, etc. It's beyond the consistency. It's also like that really makes the lives of everyone simpler. When you know everything is perfectly formatted, then you can do like massive search and replace, etc. in a much more like reliable way. So that's also helpful.
So one last thing to think about for both contributors and reviewers.
Yeah. So I don't know. Like, was there anything else that kept you busy this week, Fabio?
I noticed a new subsystem entered.
Right.
I don't really know a ton about it, but it's actually very interesting. It looks like we now have a RFID subsystem. And
not sure that we do have it, but it's in the works. I guess I noticed as well. It's so like for many. I mean, whenever I started with Zephyr a few years back, ever since, like almost every other week on Discord, one way or the other, you would have people being like, "Hey, how do I do RFID and NFC and whatnot with well, I guess NFC is not maybe strictly the same, but how do I do that with Zephyr?" And sure, I mean, this is when you think IoT and like small battery-powered devices, etc. Many of them probably need or could make use of RFID. So there is a pull request 91254, which again we will link in the show notes.
Great podcast material, great podcasting.
But it looks like it's already in a pretty good shape. Like there's a like a code sample, etc. Not a code sample, but a driver implementation. Pretty good documentation. I think. I mean, personally, my call to action would be have a look. Like if you care about or if you've been wondering about RFID in the past, do have a look. This still needs to be like reviewed more thoroughly in terms of API, etc. But from what I see, at least, it looks pretty good, pretty promising.
Yeah, it looks like it supports just a single device from ST at this point. I know there's a bunch of vendors that have devices. NXP, I think it's very big in NFC. So yes, it would be probably cool to have other vendors involved and making sure that the subsystem is developed in a way that works for everybody.
Yeah, totally. And I'm sure there's also some implications in terms of like making sure that it's low power, etc. Because usually those devices you want them like, they would be on battery, etc. So, but I think that's pretty cool.
Yeah, and for subsystem, I think there is a formal requirement that a subsystem is merged with support for two devices from two different vendors for obvious reasons. Subsystem works.
Yeah, don't want to necessarily digress. I'm not sure that's how it's worked. It's for the subsystem to graduate for the API to become to move from experimental to being considered quote unquote unstable. I think this is when we kind of have a requirement like, hey, you cannot claim that your API is in the process of becoming stable if you still only have one implementation in tree. You would need at least two.
Right. Cool. Do you want to talk about your current side project?
When's the last time you went to the doctor, Fabio?
Oh, that's a question I don't want to answer.
Okay, yeah, that's fair. Well, so as a joke, I wanted to call this podcast the Zephyr pin lock doctors, as I guess a really, really bad joke and really bad pun, with like the spin locks one may use in real-time operating systems and whatnot. So Fabio, you wouldn't let me have it.
I
So I
requested.
still want to have a doctor somewhere in the Zephyr ecosystem. So one thing I did, and the pull request is out there. I will put a link in the show minutes and notes. I think it's like probably the 10th time I'm attempting to do it, but I think this time I might be up to something. There might be in the near future a DT, a device tree doctor available in Zephyr, which is basically here to help with what we hear all the time. Newbies, Zephyr newbies, including not so newbies, tend to spend quite a lot of time figuring out what is all about, like those weird errors you get when you try and build an application, and you get weird DT, ORD, blah blah, things where that basically kind of seem to be related to device tree not being properly configured. But like, what does that mean exactly? Does that mean that I forgot to enable a device tree node, a device in my device tree somewhere? Does it mean that maybe my subsystems are not in a good shape and I forgot to enable that particular subsystem that would make sure that there is an actual driver available for such and such node? Like, yeah, those, I think those who know, right? And that the kind of errors I mean. And so, yeah, there's some experimental work, but pretty promising, where basically by looking at the error logs, you can do a lot of the stuff that one would be able to do manually if they know where to look in all those files that the Zephyr build system generates automatically and all those macros, etc. The tool basically helps you make sense of those macros automatically. And so essentially you forgot to enable the regulator subsystem, and yet somewhere in your code something depends on a regulator driver being there. It will tell you, hey, maybe you forgot to enable config_regulator. So yeah, I think have a look. I mean, I think it's it could probably do even a lot more than it does already. But I was quite excited that it finally kind of works, and it's really just a few lines of code in the end. I've actually tested it with. So yeah, don't want to digress too much, but it does look at the compilation logs. So it's somewhat depends on which toolchain you use, but it works well with GCC and like the Zephyr toolchain. But I actually tested it with LLVM as well. It works just the same, and it works well as well. So that's cool.
Yeah, I think that if you could cover the most common use cases, Zephyr SDK and LLVM, I guess that would be plenty good. So this is meant to cover all of those errors that come from weird interaction between auto-generated files and driver using macro to reference objects. And the whole thing is a bit obscure, and with the currently the only way of debugging it is you have to know how the internal works, and you have to be somewhat familiar with manually inspecting the generated file, which honestly is something that I think a developer should learn anyway, but it's probably not the first thing that you should learn. And these are the errors that you're going to find the first time you're going to try to use it. And as you mentioned, yeah, you forgot to enable a subsystem. Your driver is trying to use it, and you get an error at the linker stage. Like, what's going on there? So yeah, great job. I saw some demo of your script, and I have to say I'm quite impressed.
Yeah, so, and some, I mean, that's one link we will also put in the notes. What you just described, Fabio. We have actually really good device tree troubleshooting documentation with lots of tips and tricks. I guess hopefully if the DT doctor becomes a thing, like the number one tip will be, try to use DT Doctor first, but then there's also many other like useful tips to know where to look to figure out why your compiler is complaining or why your linker is complaining. But yeah, I would be really interested in hearing people's thoughts if they give it a try, and and I'm sure it can only become smarter over time. That's how doctors work, I guess, right? Like they study for years and then they become really smart. Right now, it's actually reasonably smart already, so I'm quite happy.
Are you convinced about the name? I have to remind you that at the time Gerard tried something like this and called it Mr. Macrobatics.
I don't know. I'm not stuck with the name. I kind of like it though, so we'll see. But that's one of the things where you can feel very free to comment on the PR. I'm also fine if this is only called the GT diagnoser tool or whatever. But yeah. All right, I think that's what we had for this week. This was episode 1.5. So what should I say now, Fabio? Like this was the second episode.
I'm not sure. I think we should not even try counting them.
Right. So yeah, by now you already know that we are on basically all platforms. So you might be watching / listening to us on the Zephyr YouTube channel or on iTunes, Spotify, etc. Don't forget to subscribe, and we will be back next week. Bye.
Bye.